this slide. Good morning, everyone. My name is Linjun. I'm a code fellow from Digital Twin Group, working with. Can make to the first slide. Yeah. So today I'm very happy to be here to share with you some my recent work have done in this program. As you can see in the title, my research is mainly focused on enhancing the interaction between human users and our digital twin system for built infrastructure management. First, I would like to introduce my presentation by asking several questions. Please help me on these questions and raise your hand if you found any of these questions applies to you. So my first question is that how many of you are using AI in your study or in your research and study, such as ChatGPT, Cloud, and Gemini, whatever? Yeah, I think AI is completely changing our life. And my question is that I believe most of us are from civil engineering and construction management. So in your opinion, will digital twins, AI, robotics can positively improve the practice for construction and infrastructure management? Yeah, I think we made agreement on it. And my last question is that, let's say this is an AI-powered digital twin system for built infrastructure management. You can think of it as a more advanced Revit. So how many of you feel confident that you can quickly be familiar with this platform and use it to address any potentially encountered tasks for infrastructure management? Yeah, I only see a few hands raising. So actually, it reflects a huge gap amongst between these advanced technologies and their practical applications in the real world. Based on a recent report released by Future.now, it shows that the use of AI and digital technology in construction management has been raised by 29% from the year 2024 to the year 2025. However, more than 85% of workers, they're actually unable to address all 10 common tasks when using these emerging technologies. And because of this, only 2 out of 10 are willing to use these technologies in their routine work. So what causes this issue? So actually, for almost existing digital systems in every domain, rely on a GUI-based interaction interface. Basically, it includes a lot of icons, buttons, tools embedded in different modules. So in order to address any tasks the users is going to encounter in the real world, they are expected to be very familiar with this operation system by navigating on and trying different tools to arrive the final result, which pose a very high learning cost and training curve, and it would be much more problematic for large-scale infrastructure, which includes a huge amount of data set. So it makes me wonder whether we can design another interaction mode to facilitate the interaction between human users and our digital system to help users use our digital twin system to address any infrastructure management task. So with the recent advances in artificial intelligence, we designed a large language model-based multi-agent system. And the framework of our method is shown on the right side. As you can see, our method is kind of two-layer architecture. As you can see on the top of this architecture, we have a team agent, which is responsible for communicating and interpreting users' needs. And if the task from the users are very complex, then the team agent can break down these tasks into several simple subtasks and assign them to some specialized member agents. each member agent is designed for different specific purpose, and they are allowed to directly interact with any certain modules already embedded in our digital twin platform by working different tools for data query, processing, analysis, visualization, and finally, the lead agent will integrate all the information for the member agent and then generate a cohesive result returned to the user. And this process is fully automated. And we developed a prototype based on this framework. It's particularly for the highway infrastructure management in the UK. So compared to traditional GUI-based method, the user needs to click every piece of buttons in order to get the information they want. So compared to our method, in our methods, the only thing user needs to do is to tap the description of their tasks in the chat box. Then the multi-agent system is gonna take over this task and automatically interacting with digital twin. And finally, it will display the final answer in the chat box as well. So as you can see, this interaction mode is much more, at least from my perspective, is much more convenient and user-friendly. Then we designed a user-centered experiment to validate the performance of this multi-agent system-based interaction mode. In this experiment, we recruited 80 participants from either academic and industrial background, and each user is asked to interact with digital twin by using both GUI-based interaction mode and our proposed large language model multi-agent system interaction mode. And after completing each task, the user needs to fill out several questionnaires to record their task completion time, cognitive workload, and their opinion on usability of each system in helping them address different tasks. Also, we separate the participants into two different groups based on whether they already familiar with the original GUI-based digital twin interaction mode, because we want to test whether our method can benefit all users, no matter they are already familiar with this digital twin operation system. So this slide summarizes the completion time from two groups of users. As we can see, our method can benefit all users, no matter, regardless of their prime digital twin experience. And overall, our method can reduce the completion time by approximately 62 to 18. And we also collect the NASA score reported by different users in different tasks. Basically, generally speaking, a higher NASA score means that users have experienced a higher cognitive load when they conducting certain tasks. As we can see, our method can greatly reduce the cognitive workload when they conducting different tasks. I would say this result is quite promising because for our humans, we only have limited cognitive resources among certain period of time. So if we put too much time on system operation, we would pay less attention on checking whether the result from digital twin is not all right. So in this case, we are more prone to make a mistake under this circumstance. And because of these improvements, the users believe that our method, multi-agent-based interaction mode is much more useful than the traditional GUI-based interaction mode. To sum up, in this study, we developed a large language model based on multi-agent system to enhance the interaction between human users and digital system for built infrastructure management, and the preliminary result is promising. Of course, there's some work we need to do in the future. For example, we found that almost 2/3 time the user need to take is to tap their task description in the chat box. So in future, we plan to integrate some voice recognition modes. So in this case, the user can directly talk with digital twin to help them conduct any tasks in a more efficient and user-friendly manner. Yeah. Thank you. And this is all my presentation. Any questions?